start recording. Okay, so these kind of functions are called abstract functions. They are intended for to be parts of the interface, but they are not supposed to be implemented, and the compiler knows about it. If you try to implement this print check, the compiler will give you error message. Okay, and if you try to make an object of this class employee, the compiler will tell you that no, you are not allowed to make an object of this class employee. Okay, so remember the question that I asked you: why, if I am not going to implement it, why should I have line 25? That's an important question, and that's when the answer is more important than the question, because it is supposed to be used this way. For some classes, remember these classes that I showed you before. In Java, this interface means none of the functions are implemented. There are no implemented functions inside this interface or collection. Okay, these are purely abstract classes. Okay, there are no data members in it, and there are no implemented functions in it. They are full of function prototypes. There are function interfaces but no implementations. Okay, so these are concrete classes. These have to implement everything. Okay, so I am not inheriting any implementation. I am inheriting only the interface, and most of the time this is more important than the inheriting the implementation itself. Okay, go back to the slides. So for the kind of a repeat for the online people, and I while I'm talking about it, I talk many neat stuff. So we are talking about this hierarchy now. A is the parent, B and C are the children. Okay, E is the child of B and C. A is the ancestor of E. Okay, A is the ancestor of both. A is the ancestor of B, C, E, and D, but A is for the E ancestor relationship is more. Okay, usually we say these are the children, but for the E it is ancestor. Okay, A is E is descendant of A. Okay, how do we say this in Turkish? A, E'nin dedesi ya da ceddi, geçmişi. Ceddi bu bunun. A'nın nesi? Torunu, ama torunun çok daha gerisine ne denir? Aşağısına gittiğin zaman. Ha? Soyundan geliyor. You understand what I'm saying, okay? These kind of terms, ceddi, dedesi, torunu, okay, or ancestorship, these are valid for the humans, but usually, all the time, sorry, not usually, if there's an inheritance going on, this person is dead, right? Okay, that's what we say. In this case, no, class A, B, C are well and alive and they are used, okay? Even if they are abstract classes, like they have functions that are not defined, they are alive. Okay, so it is inheritance terminology. So don't think this inheritance as like the inheritance of the humans, okay? It is a little bit different. It's a little bit different. Okay, good. So we talked about this. So let's talk about the constructors in the derived classes. What did we say? We said that everything in my base class is inherited. Well, constructors, destructors, I'm going to come back to that one. Well, it's too far away. Let's talk about this. Okay. Our constructors, destructors, copy constructors, assignment operators. It looks like I am counting the big tree, right? They are not inherited. Okay. They are available, but they are not inherited. Well, that means what? Your base class's constructor doesn't become your constructor. Okay. Your base class's constructor is different than your constructor. Your base class's constructor is inherited, but it is not your constructor. Okay, so it is a little bit different than the other functions inheritance. Okay, base classes constructors are not inherited in derived classes in the usual way. They are inherited, but they don't become your constructors. So what do? You write your own constructor, including the copy constructor, no parameter constructor, and everything. Okay. You write your constructors, but while you are writing your constructors, you get help from the base classes constructor. You say that I am not going to initialize this part of my class. I will call the employee constructor. Okay, that's what we do with the constructor in the derived classes. And base class constructor must initialize all the base class members. So base class should be a standalone class. Okay, it does everything related to base class data members. And as a derived class, you call the base class like we do here. Okay, hourly employee. I am an hourly employee. I know I am an employee. I get this 1, 2, 3, 4 parameters. Okay, from the customer. This name and number. Okay, I don't know how to use them, but the employee class knows it. Whatever it does, it is its responsibility. So I will call the base classes constructor. This is like calling the day of year classes constructor. Remember when you do the composition? Okay, it's very similar to composition. It is very similar to initializing one of your data members. Okay, call the base classes constructor, and for the rest, initialize your data members. Okay, it's like this. Remember this one? If I have an hourly employee, Ali Yılmaz with the TC kimlik numarası here, and hourly employee worked 50 hours and per hour 20 liras. Okay, so this is my object H1. It has two parts. Okay, one is the employee part, the other one is the rate and hour part. So this whole thing is H1. Employee part has to be initialized by this constructor. The rest will be initialized by our new statements. Of course, the whole thing, this whole H1 is initialized by our new constructor of this hourly employee. Okay, but we get help from the base classes constructor. Okay, remember this column. After the column is the initialization section for the constructors, and we do that. Okay.
Connection went bad again. I don't know if it's a problem.
It says my network quality is bad. Do you guys hear me okay? Online people?
Yes,
you hear me? Is my sound breaking?
No, there is no breaking, sir.
Okay, thank you. Who is this guy beklemede? Just change your picture in your profile, okay? This guy is scaring me. Is that your picture? I don't think so. Did anybody see this person? For some reason, today people are laughing at my jokes. But I don't like this picture. Who is this? Mustafa Berkay. Mustafa, are you there, Mustafa? No. Tell him anybody knows it. No, this is scary. No. Why don't you use your own pictures? Okay. So we talked about this, and this is the no parameter constructor. So what happens if I don't? Let's go to our employee CPP. Let's go to the constructor. If I take this 3 stuff out, why don't I do this? Because you won't remember what I erased. Okay. Do this. Okay. If I do this, let's make it syntactically more correct. If I do this, would this code compile? Yes, it will compile, and I'm doing a bad thing, yeah. I did not initialize the wage, okay. I did not initialize the hours. The worst thing is I did not initialize my employee part. But luckily, compiler will call the no parameter constructor of the base class, the default constructor of the base class. Okay? Default constructor of the base class. The compiler will call it. And this double and this double, since their default constructors don't do anything, they will be kept as uninitialized, which is a bad thing. Okay? So if you don't call the base classes constructor, the compiler will automatically call the base classes no parameter constructor. Okay, you can do the same thing again. If I do this, okay, a very, very bad code, but it's compilable. The compiler will call the base classes constructor, default constructor, no parameter constructor, and my wage and the rate will not be initialized. Again, very bad code, but bad code doesn't mean that it is not compilable. It is compilable. So, bad code is bad code, but compilable bad code is even worse. Okay? So let's take this out. And that's the rule actually. Okay. Default version of the base class is called if you don't call anything. Should always invoke, but the rule is this. Always initialize your data members, whatever it is, okay? And always call your base classes constructor, even if the default behavior is calling your base classes default constructor if you don't write any. Try to write this kind of code, okay? Just make it explicit, make it that I am calling this one. Okay. Constructor no base class, we talked about this. Don't do this. Okay, I did this before. I mean, doing this, writing this code and writing this code is exactly the same. The compiler will call your base classes constructor, but don't do this. Okay. If you do not, the base classes constructor automatically just, because when I read this, I don't know if you do this on purpose or if you just erase it, or I don't know. Okay. So don't do this. That's why there is a red mark here. Okay, so we talked about this private class, okay, base class private data. We inherit everything. There is nothing wrong. That sentence is correct. We inherit everything that the base class has, including the privates, but you still cannot directly access them. Why? Because those are the private data and function members of the base class. When I have implemented that class employee, because remember the employee implementation of the employee, I did not know that anybody is going to derive from me, okay? So my assumption is I am just a class. Whatever private is private to me, nobody is going to have access to it. That was my assumption. If somebody derives from me, if somebody derives from me and changes some stuff, my private stuff, maybe that will violate some of the rules that I've used in my implementation. So that is not possible to modify or access my private data or private functions. So that rule stands. We say that whatever private to a class, it is private. No matter the outside classes are, doesn't matter if they derived or outside classes, those are not accessible. Okay. Private member variables can only be accessed by naming their functions. Okay, that's it. Okay, same holds for the private member function, etc. Cannot be accessed outside the interface. Okay, so this is reasonable. This is the way to go. Don't allow your anybody other than your class to access your private data or functions. Okay, some people say that, well, this is too limiting. I mean, if I have a relationship between employee and hourly employee should have access to the private data because there is a relationship between them. Other people say that this is the reasonable approach. Okay, private is private, so they found kind of a solution. Like in between, they have invented this new qualifier, access qualifier. Protected. Protected is between public and private. Okay, so there is a protected section in your class. if your data member or function member is protected, it behaves like private for the outside code. Anybody outside of your class will not see it. It looks like a private. But if you are a derived class from the base class, then protected will be visible for you. Okay? New classification of class members allows access by name in derived classes. So if you are in the derived class, protected data and function members will be visible for you, but if you are fully a stranger, then it will be private. Okay? So many object-oriented, pure object-oriented people feel that this just kind of violates the information hiding and encapsulation principle or information hiding principle. What did we say? Anything private should be private, should not be accessible from outside, even if it is derived. That's true for the private, it's true, but for the protected, it is not. For the protected, it is private. Protected members are private for the outside strangers, outside classes, outside functions, but they are available, they are visible for the derived classes functions. Okay, so if you use this in carefully, don't make everything protected or in your classes. Then you should be fine. Kind of a compromise, okay? Compromise between public and protected. Some people don't like it, but we keep using it all the time. Okay, this is called protected. You had a question? Yeah.
Is it available for private inner class members?
What?
Inner class. Disqualified.
Inner class?
Yeah.
Well, sure. Yeah. Well, inner class could be public, private, or protected. Yeah. It is. I mean, it is just a third access qualifier. Wherever I can use public or private, I can use protected too. The meaning is, I mean, without inheritance, protected simply means private. Protected is only meaningful with the inheritance. Without the inheritance, protected is simply private, right? With the inheritance, things are different. With the inheritance, the named right classes, protected are visible. Okay. So another important topic is this, redefinition of member functions. Okay. Remember, there is no redefinition of member variables. It's just redefinition of member functions. Okay. Inside the interface of a derived class, if you don't like how the base classes functions behave, you can change their behavior. Just redefine your function. That's it. Okay. We can either define new member functions or we redefine the inherited functions. Okay. And this is very important, redefining versus overloading. What was overloading? Overloading is defining another function with the same name but with a different signature, right? That was overloading. So you can have two different functions named f in the same scope, as long as their signatures are different, okay? Redefining is different. Redefining say that I don't like that print check function. I am defining another function which will have the same name, but it will behave differently. So I am not going to use the old one. Old one goes away, okay? When you say print check is now this. So it is different, okay? So redefining is done with the same signature. Redefining is done with the same signature. Overloading is done with different signatures. Okay? So this difference is very important. Redefining and overloading.
And you cannot redefine in the same scope too.
You cannot redefine what?
You cannot use redefining in the same scope as the...
If you try to redefine it in the same scope, then you are making another implementation of the same function. That's the compiler error. Because you are trying to write a function two times with the same signature, right? Either you need to change the signature a little bit, so it is overloading. And again, Redefining is only meaningful with within the concept of inheritance. Without inheritance, redefining is not meaningful, it's not possible. It only happens with inheritance. Okay, good. We talked about this. A function signature is, okay, function's name and the parameter list and etc. We know the signature doesn't include the stuff. Well, I mean, if you need to do it, we don't do this, but for example, here, I have an employee Jane, I have an hourly employee Sally, okay? When I say Jane dot print check, okay, employees print check will be called, which will terminate the program, remember that one. But when I say Sally dot print check, it will call the hourly employees print check function. If you like to call the print check function of the employee on Sally H, remember Sally is an hourly employee, you can do this if you like. I am going to, remember, I inherit everything, okay? All the things are available to me, including this redefined print check function. If you like to call the original print check function on your derived class object, you can do this, but this is not typical. Usually we don't write this kind of stupid code, okay? I mean, if you need to call the base class print check function, then why are you redefining it for your case? But it is possible if you like to do that. So don't use anything like this, even though it is possible, not typical, okay? Very rarely used. And we will see. Don't confuse this with calling the constructor within your constructor, okay? Sometimes, remember when I write my constructor, I call the constructor of the base class. So I inherited it, I am writing my own constructor, I am getting help from the base class. Sometimes I do this with the functions too. I am redefining a function, okay, I am redefining a function. While I am redefining it, I am using the base classes function. That's okay, we can do that too. But usually, as a customer, I don't write this kind of code. Okay, and this is what I have talked about before. Everything is inherited, no exceptions. But constructors, even though they are inherited, they don't become your constructors. You have to call them specifically. Your destructors, the base class of destructors, they don't become your destructor, okay? It is the destructor of the base class. It is still available, but it is not your destructor. You need to write your own destructor. Copy constructor, again, base class's copy constructor is not your copy constructor. You have to write your own. Again, assignment, the same thing. So again, remember this one, big three. Big three says that there is a default meaning for destructor, copy constructor, and assignment. If you don't define them, and if the default behavior is okay, then they will be fine. The same thing is here. If you don't define your destructor, copy constructor, and assignment operator, their meaning will be the default meaning. It is not the inherited destructor, copy constructor, assignment operator, because they are not inherited. Base classes, constructors, including the copy constructor, destructors, and assignment operators will not be your functions. You need to write your own, and if you need you call the base classes copy constructor or the assignment operator. Okay, so this is important. Big three is important. Paying attention to big three in your inherited functions, inherited classes are more important. The book, let me show you, I am out of time, but let me show you one example from the book. Okay, the book revisits this example of PFRAD, remember? Partially filled array for doubles. This is our PFRAD. No changes for this one. Okay. Since this one uses a C double array, capacity unused, I have defined my copy constructor. I have defined my assignment operator and the destructor and etc. Okay. The book says that I am going to derive from this class. I am going to make a new class named PFRAD backup. This class is exactly the same as the PFRAD. See, this is exactly the same as PFRAD, but it has a new capability. It can take backups of the array. So when you, let's say if you have 50 doubles in it, you say backup, I am taking the backup of this array. Later you added more data to that array, okay? You modified your array and you decided that you like to restore your original array, you can just call the restore function, okay? So these two functions are the new functionality of our backup class. This backup class is exactly the same as PFRAD. Indexing works, okay? What kind of other things we have? Add element works, full works, get capacity works, empty works, indexing works, and everything, okay? Other than that, this backup has backup and restore, two new functions, okay? So that's what we are going to look at tomorrow. Inheritance hierarchy with our PFRAD. Okay, any questions? Where is my attendance? Can you bring it me? Yeah. You have a question?
Is it using the index operator of PFRAD?
Yeah. Yeah. That operator is over. That operator is inherited too. Okay. Assignment operator is not inherited, but the index operator is inherited. Let me show you one example here. Okay. So there is a PFRAD backup object A with this capacity. Okay. And I keep adding elements to this A, like a regular PFRAD. See, this is not PFRAD, this is PFRAD backup. Okay. I keep adding elements, and then what do I do? Get number of used, and from 0 to count, I use the index operator to print them all up. Then I take the backup, and then I empty my array, just erase everything, and try to print this stuff out, and you will see that there is 0 elements in it. Then I restore it, and you will see that I get everything back. So as you see, this object A behaves exactly the same as a PFRAD object. The only thing is that it has this backup available and restore available. Okay? Any other questions? So this will be a good exercise. A good exercise of big three, dynamic memory allocation. Also a new way of looking at inheritance with these three stuff. Okay? Good? Okay, thank you. I will see you tomorrow. Read this chapter number 14 from beginning to the end. And while you are at it, read chapter number 15 too. Okay? 15 is about polymorphism. Yeah?
Can you put the reason why
Come here and ask because people are...
Güncel attendance'ı paylaşabiliyor musunuz şeyden Teams'ten acaba? Şeyi takip etmek için.
Kaç ders geldin gelmedin diye.
Efendim?
İlhan'a sorsan onu.
Tamam.
İlhan'a söyle. O baksın.
Hocam bir de ben bir şey sorayım bu yoklamak için.
Sor.
%30 bu sene başına ama siz onu %25 mi dediniz daha sonra?
Hayır, 3 dersten birine gireceksiniz dedim. Haftada 3 dersimiz var. 3 dersten birine gireceksiniz dedim. Midterm'e zaten herkes geliyor. Dönemde de 14 tane dersimiz var. 13 derse geleceksiniz dedim. Bu yoklama konusundaki hassasiyetiniz beni çok şey yapıyor ya. Duygulandırıyor yani. Ya niye 15 derse gelmiyor? Herkes 13 tuttu. Fazla geldiği zaman bir şey olmayacak arkadaşlar ya.